Chapter 2. We're going to be looking at quadratic functions and polynomials of degree 2 and higher. Section 2.1, Quadratic Functions and Models. The difference between ordinary and extraordinary is that little extra, Jimmy Johnson. So a quadratic function is a function who has the form f of x equals ax squared plus bx plus c. Notice that the highest exponent is a 2. And a parabola or a quadratic function is going to open upward if the coefficient in front of a is greater than 0, and it's going to open downward if the coefficient in front of a is less than 0. The graph looks like a parabola, or we call it a parabola. It's more like a U shape, and this dotted line here is called the axis of symmetry, and it's basically this side of the parabola is symmetric to this side of the parabola. The bottom lowest point of the graph or the highest point of the graph is called the vertex. And that's where the axis of symmetry intersects. Determine the vertex, axis of symmetry, x-intercepts, and y-intercepts. So for this graph, we say that this bottom part, this is called the vertex. And we say it has a minimum point since it's the lowest part of the graph. This point here is your y-intercept, since it's crossing the y-axis. So this is your y-axis. And this is an x-intercept. And this is an x-intercept. The axis of symmetry is this dotted line at x equals 1. Okay, notice that the y-intercept is -3, and notice over here we have a -3. So anytime that we have a general form, C is your y-intercept, if it's written in this form. Okay, over here we have our vertex, and this time we say it's the maximum, since it's the highest part of the graph. We have this as your x-intercept. Okay, so remember these are also called zeros. And this other x-intercept is at x equals -2.414. The y-intercept is at y equals 1. And the axis of symmetry is at x equals -1. Okay, so notice your y-intercept is 1. And here's the equation, the 1. What are the x-intercepts of the first graph? So the x-intercepts, we said were x equals -1 and x equals 3. So these 2 points. What are the zeros? Zeros are the same thing as x-intercepts, it's just a different name. What are the roots? Roots, again, is the same thing. It's just a different way of asking for the same thing. And then solutions. So those are all going to be the same thing. Confirm the solutions of the function algebraically. So remember, when you want to confirm algebraically, the solutions are the x-intercepts, zeros, roots. That means that y is equal to 0. So we have some options here. Whenever it's quadratic, number 1, you can see a bit factors. And number 2, you can use the quadratic formula. Okay, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. And this comes from using the general form. Okay, so we can factor here. Let's factor first. If you're not able to factor within the first minute, this might not be factorable. So then you might need to use a quadratic formula. So 3 is 3 times 1. I need the bigger number to be negative. Set each factor equal to 0. Okay, so those are my zeros. If we want to use the quadratic formula, I'm going to write it here. Then it's good to list down what A, B, and C are. So in our equation, the number in front of x is always going to be A. So in this case, A is 1. B is a number in front of x. In this case, is -2. And C is your constant. So we plug that information in. So negative B is -2 plus or minus -2 squared minus 4 times A times C. So we get +2. 4, -4 times 1 is -4 times -3, +12. 4 plus 12 is 16. And the square root of 16 is 4. 2 divided by 2 is 1. 4 divided by 2 is 2. So from here, we get two answers. X is equal to 1 plus 2, and x is equal to 1 minus 2. And so you can see we get the same two answers. Okay, so the next one, the standard form of a quadratic is given by ax minus h squared plus k, where hx is the vertex and the axis of symmetry is at x equals h. Okay, so whenever we have this form, hx is going to be your vertex. So steps for graphing a quadratic function. First, if your function is not in standard form, then we can write it in standard form. We identify the vertex, the axis of symmetry, the y-intercept, and the x-intercepts. So if we look at example 2, this is already in standard form. And so recall the standard form is this right here. So number 1, to get the vertex, or number 1, it's already in standard form. Number 2, we want the vertex. So the vertex is going to be found by h. Okay, so if you notice here, h is negative. So when we find the vertex, we change that sign to positive. And the k is going to keep the sign. So here's positive k, we get positive k. So the first one is opposite. The second one stays as it is. So here my h is going to be opposite of what's in here. So instead of -3, we get 3. And then my k is this outside number, which is -4. Step 3, axis of symmetry. So the axis of symmetry is your h. So we write it as x equals 3. Then we want the y-intercept. So for the y-intercept, we let x equals 0 and solve for y. So here's my equation. So I'm going to let y or x be 0. So 0 minus 3 is negative 3. Squared minus 4. Negative 3 squared is 9. Minus 4, so we get 5. So my y-intercept is y equals 5. And we can write it as 0, 5. Okay, and then the last one, number 5, is the x-intercept. So for this one, we let y equals 0 and solve for x. So here I can add 4 on both sides. And I can take the square root. The square root and the 2 become a 1. Square root of 4 is plus or minus 2. So we add 3 on both sides. So one answer would be 3 plus 2 is equal to x, and the other is 3 minus 2 is equal to x. So this answer here will be x is equal to 5, and this one is x is equal to 1. Once we have this information, we can plot it. So x is equal to 1 is right here. 2, 3, 4, 5 is right here. Your y-intercept is 0, 5. Your vertex is 3, negative 4. Okay, so then we can sketch the graph. Okay, the axis of symmetry, again, is this line that cuts the parabola in half. So here we have 1, 2, 3 spaces this way. So 1, 2, 3 would be where your other point is. So they are symmetrical. Step 3, or example 3, graph f of x equals x squared minus 4x plus 3. Determine the domain and the range. And actually on this one, it also asks for the domain and the range. So the domain is all the x values that we're using. Since we have these arrows, that means that the graph will keep going on forever, which means that we'll be using all these x values because the graph extends this way and this way. Now the range, the lowest y value is this one here, which is at negative 4. And then we start using all these y values. So from negative 4 to infinity. Okay, so the next one, notice that it's not in standard form. So the first thing we want to do is write it in standard form. To write in standard form, what we're going to do is we're going to rewrite the problem a little bit different. So we're going to have f of x is equal to x squared minus 4x. And then I'm going to leave a little gap here. And then I have plus 3. So to write in standard form, the first thing you want to make sure is that the number in front of x squared is a 1. If it's not a 1, then we're going to have to deal with that. So if it is a 1, then the first step is to take your b, which is the number in front of x, and we're going to take half. So half of negative 4 is negative 2. Yeah, so that's the first step. Once you take half, then you're going to square it. So negative 2 squared is equal to 4. And then last, we're going to add 2 parentheses. we're going to add a positive 4 and a negative 4. So basically we're adding 0. So I'm going to add plus 4 minus 4. So notice here plus 4 minus 4 is 0. So we're not changing the problem. We're just making it look different. Okay, so then what we want to do is we're going to keep the positive 4 in the parentheses. And then we want to remove the negative 4. So this negative 4, we're going to bring outside. But if there's something out here in this parentheses, before we remove it, we would have to multiply it. And in this case, there's a 1 here. So 1 times negative 4 is just negative 4. And then we have our plus 3. By doing this, we can factor what's left. So in here, we're going to get x minus 2 and x minus 2. Negative 4 plus 3, negative 1. Notice here my minus 2 is actually what I get when I take a half. So that's a shortcut. Whatever you get half of here goes in this parentheses. Since I have two identical factors, I can write them as x minus 2 squared minus 1. So now your equation is in standard form. So step 2 is to find the vertex. So here I have a negative 2, so my h is going to be the opposite, so positive 2, and then I keep my k as negative 1. The axis of symmetry is always that h, so x is equal to 2. The y-intercept, we let x equal 0, so y is equal to 3. Notice here that you get 3, and in the equation, that's our letter c. So when it's in this form, we can say that this is going to be your y-intercept. And then last, your x-intercepts. So we let y equal 0. And then you can try to factor. So x minus 1, x minus 3, negative 1, negative 3 is positive 3, negative 1 plus negative 3 is negative 4. Set each factor equal to 0. So x is 1 and x is positive 3. Again, if you don't want to factor, then your other choice is to use a quadratic formula. So here I have x equals 1, x equals 3. My y-intercept is 0, 3. My vertex is 2, negative 1. So I'm going to graph here. My axis of symmetry is this dotted line. So since I have two spaces from here, I'm going to have two spaces over here. And so I can draw my parabola. Again, this extra space, I get it from the fact that the axis of symmetry, which is running here in the middle, cuts the parabola in half. Okay, let's try one more. Example 4. Graph f of x equals negative x squared plus 2x plus 8. So first, notice that it's not in standard form. So we will need to write it in standard form. So to do that, we're going to have to check to make sure that the number in front of x is positive 1. And in this example, you can see that it's not a positive 1. Instead, it's a negative. Okay. So I can rewrite this as negative x squared plus 2x, and then we leave a little space, plus 8. And then we need to take care of this negative. So I'm going to factor it to the front. And so that's going to leave me with x squared minus 2x plus 8. So now we can take half of the negative 2. So half of negative 2 would be negative 1. And so then we square it. So we get positive 1. So this positive 1, we're going to add to our parentheses, but then we're also going to subtract. Okay, so now we have negative x squared minus 2x plus 1. And then we're going to factor out this negative 1. But in order to factor out this negative 1, remember what I mentioned earlier, since you have a negative out here, we would have to multiply this negative times this negative 1, which is going to make it a positive 1 plus 8. Okay, so the negative 1 that we want to remove becomes positive because negative times negative would be positive 1. So now we can factor. So in here we have a 1 and a 1. Since it was negative 1, that's what we're using for our values. 1 plus 8 is 9. I can write this as x minus 1 squared plus 9. And then I can get our vertex. So the vertex here, h, is the opposite of negative 1, so that's 1. And then we keep the sign of 9. Axis of symmetry is that x equals 1. The y-intercept, you can use your standard form, which is right here, or you can use this form up here. So again, your y-intercept is just this number out here. And the reason is if x is 0, then everything becomes 0 except for that number. So my y-intercept is at 0, 8. My x-intercept, you can also use this form and try to factor, or you can use the standard form. I'm going to go ahead and use the standard form. Okay, so we let this be 0. I'm going to subtract 9 on both sides. Divide by negative 1. So I get 9 is x minus 1 squared. Take the square root. The square root and the 2 become a 1, so they cancel basically. Square root of 9 is plus or minus 3. We're going to add 1. So we get 1 plus or minus 3. So one answer is x equals 1 plus 3, and the other is 1 minus 3. So 1 plus 3 is 4, 1 minus 3 is negative 2. So my x-intercepts are x equals 4 and x equals negative 2. Okay, we can plot this. X equals 4 and x equals negative 2. The y-intercept is at 0, 8. No, yeah, 0, 8. So up here. And the vertex is at 1 and 9. So a little bit further out. Notice that we have a negative in front of the x squared. So that means that this should open down. And the axis of symmetry is this line here. Okay, the domain is all real numbers since we're using all the x's. And then the range, the lowest value for x that we're using is the negative infinity down here. And it goes up to the highest point for y, which is going to be 9. Okay, let's try the next one. So first we want to write it in standard form. So first I write the two terms together with a gap. And now the number in front of x squared is not a 1, so we need to take care of this. So we can factor out a 3 since it's common to both terms. Oh, so if I take a 3 out of here, I get 3x squared. And if I factor out a 3 from 6, then I get 2. So you can see that 3 times x squared is 3x squared, and 3 times negative 2x is negative 6x. Now we can take half of this number. So half is negative 1, and then we can square it, which is 1. So I'm going to add 1 and subtract 1. So I get x squared minus 2x plus 1. Remember, this negative 1 is what we want to remove. Before I can take it out, though, I have to make sure that there's nothing to multiply out here. Since I have a 3, then I have to multiply 3 times negative 1, which gives me a negative 3, and then plus 4. This here I can factor now. The half was a negative 1. Negative 3 plus 4 is 1. I can write x minus 1 as x minus 1 squared plus 1. So this is going to be your general form. The vertex, your h here is going to be the opposite of this value. So 1. And then we keep the k. So my vertex is at 1, 1. Axis of symmetry is going to be at x equals 1, which is just the h value. The y-intercept, again, if you have your y-intercept, you have your equation set up in this form, then their y-intercept is just going to be this number c. So when x is 0, we just get 4. X-intercept, I'm going to use the standard form. So I let y equal 0. Subtract the 1. Divide by 3. Take the square root. Here, since we have a negative square root, then there is no real solution. There is a solution, but it's imaginary. So for now, we just write no real solution. Yep, so let's go ahead and graph this. So the y-intercept is 0, 4. The vertex is 1, 1. And notice here that your axis of symmetry is going to run through this vertex. And so this point reflects over to this side. So I can draw my parabola. And so notice that whenever you get no real solution, what that means is that this graph will never cross the x-axis. So our domain is negative infinity to positive infinity. Since we're using all the y values, we know that because of the arrows. And then the range, the lowest y value is at this point, which is 1 to infinity. Okay, next example 6. It says write the standard form of the quadratic function whose graph is a parabola with a given vertex and passes through the given points. So first, since they want us to write it in standard form, then we should write down the standard form so we can see it in front of us. And then I'm going to change f of x to y. Remember, f of x and y is the same thing, just different names. And then I'm going to use this information. This is x, this is y. Remember, your vertex is h and k. So here y is 15. We don't know what a is. X is negative 6 minus h, which is negative 4. And k is 11. So I simplify. Negative negative is positive. Negative 6 plus 4 is negative 2. So this is negative 2 squared is 4. Subtract 11. So we get 15 minus 11 is 4. Divided equals to 4a. Divide by 4. So a is equal to 1. Okay, so once we know a, we can plug the information back in. So a is 1. X minus your vertex, which is negative 4 squared plus 11. I don't need to write the 1. Negative negative is positive. And so this would be your equation. So after the finding a, then we come back to the general form. We plug in our a, which was 1. And then our h and k is what's given here. So we plug that in and simplify. So that's our equation. Let's try another one. So write the general form first. So this is x and y, h and k. So we don't know what a is. Let me just rewrite this again. So f of x I'm going to write as y. So y in this case is 15. A we don't know. X is 7. H is 5. And k is 12. Simplify. 7 minus 5 is 2. 2 squared is 4. Subtract the 12. And divide by 4. So a is 3/4. So now we're going to plug in everything that we have. A is 3/4. And h is 5. And k is 12. Okay, let's look at the example 8. Write the equation of the graph below in standard form. So same idea. In order to write in standard form, we need the vertex and at least one point. So here my vertex is this point here, which is -2 and -3. And then I can use another point. So let's pick another point. We can use, for example, -4 and -1, or you can use 0, -1. So you want to pick one that is easy, that you like. So it could be either one. So I guess I'll pick this point here, -4 and -1. You want to make sure you get a point that you can easily see the coordinates for. So y is -1 and x is -4. So y is -1, h is -2, and k is -3. Simplify negative and negative, or our x here was -2. Our x is -4, so let's plug that in. Negative negative is +2. -4 plus 2 is -2. And -2 squared is 4 at the 3. So we get 2 is equal to 4a divided by 4. So a is equal to 1/2. Plug it back in. So a is 1/2. H is -2. And k is -3. Negative negative is +2. Okay, so let's go to the next page. Okay, the path of a baseball after being hit. Well, let's look at the definitions first. Consider the function f of x equals ax squared plus bx plus c with vertex b negative b over divided by 2a and f of negative b divided by 2a. So this right here is another way to find the vertex. When a is greater than 0, then we have a minimum. And when a is greater than 0, we have a maximum. And the reason is if a is greater than 0, it's going to open up. And if it's less than 0, it opens down, creating that maximum here. The path of a baseball after being hit is modeled by that equation where f of x is the height of the baseball in feet and x is the distance from home plate. What is the maximum height? So whenever you get these keywords, maximum or minimum, and you have a quadratic equation, then this is only telling you to find the vertex. So again, the vertex, we can find it by rewriting this or using this formula, or you can rewrite this in standard form, which might be a little bit more time consuming than using this formula here. Okay, so first to find the vertex here, we're going to find the x coordinate, and that's found by using negative b over 2a. So your equation here, a is negative 0.007, b is 1, and c is 4. So I'm going to plug in my information for b and for a. So we get -1. 2 times this would be -0.14. And if we divide, comes out to 71.43. And this is in feet. Once you find your x value, then you're going to find your y value. So this is step 1. So step 2 is to find f of what you got in the first part. So we're going to find f of 71.43. And so what that means is we're going to plug in that number into every x that we see. Okay? If you plug this into the calculator, you should end up with 39.71. Okay? So your vertex is the x value, 71.43 feet, and the y value, 39.71. So this problem doesn't ask what the vertex is, but it wants to know the maximum height. So what happens here is you have two values. So here's x at 71.43, and then here's y at 39.71, and the parabola is doing something like this. Okay, so the maximum height is given by the y value, and the x value tells you where it occurs. So in this case, this here is where it occurs, and this here is your max height. Okay, so we can say the maximum height of the baseball is 39.71, and it occurs 71.43 feet from the home plate. So the max height is 39.71 and occurs 71.43 feet from home plate. For extra credit, 5 points on quiz 3 and 5 points on exam 2. Write the equation in standard form. Okay, show your work and graph.